I had a couple supercapacitors left over from a dead RAID card battery pack. It's a memory backup module, and it's basically these supercaps. And if you look at these, they are rated at, what do we got here? 34 farad at 2.7 volt. I mean, they're so large that none of my capacitance meters will read them. uh, so I don't know if you can see it, but they are actually still glowing. Those LEDs are still putting off just a little bit of light, just a smidgen. Um, I had to go out of town for business, and I charged this thing up 2 days before I left. So it was running for about 4 days. And I want to show you how much energy it takes to charge this. So I'm going to connect my leads here, and we will energize this guy up. Let's go ahead and get, there's my negative rail there. Okay, so we're going to add some power to this. I want to show you how large and how long it takes at 2.7 volts. We're going to charge this with my power supply at 5. I'm not going to go past an amp, but I want you to see how ridiculously long it takes to charge. 1, 2, 3, 4, 5. What's the fun in having a fancy calculator if you can't use it, right? So, what? 34 times 5. Do we get to watch it calculate? I think it only does it when I do squares, but oh no, you got to see it. See? It was cool. 170 farad at 2.7 volt, right? That's it's an insane amount of energy in those little guys, and it will last for days running those two little LEDs. So we're going to turn on the power supply. I'm going to disconnect the lead going to it first. Currently set at 2.5, so obviously this is what I was doing last. I'm going to turn down the current to nil. And then it's currently reading 1.6 volts on the caps. It's not putting anything out. We're going to put a little bit of current in. I'm going to allow, we'll do 1 amp. There we go. I'll just let it, it's like I'm kind of turning it up all the way now. So it's still charging. So what you'll do is you'll see the current start to go down. So as that capacitor charges up, the bank of capacitors starts to charge, we're going to see this value go down. And because now we're feeding these with full voltage, they are properly bright again. And if I disconnect our power supply, they are still lit up. We are just seeing them illuminated only by the SuperCaps. So we're going to go back and provide our power back to the caps. And if it's been talked about, this is one of the major issues in battery technology, right? We talk about green energy and renewables, and the major issue we have is battery technology is filthy. Generally, it requires disgusting amounts of heavy metals and everything else. So we're polluting the environment with strip mines, and a lot of times in conflict countries, we're not doing a lot of due diligence as a society about how we take care of energy storage. Capacitors are amazing. These can be cycled over and over again, and the construction is fairly simple. If you watch videos online for Tesla coil construction, you can turn anything into a capacitor. You can have the original capacitors were jars with electrolyte solution and some aluminum foil, basically. I mean, Linden jars, right? So Tesla coil capacitor design I used in high school was a Tupperware container with alternating layers of foil and painter's drop cloth. Thank you to the Tesla coil builders of Richmond. But that being said, so if you could store energy like this from a solar system, and you could build a large enough capacitor bank with a low enough, residual dissipation, you could, have an instantly charging battery. This charges way faster than equivalent capacity lithium ion. And if you look right now, we are still charging, so we're drawing 0.37 amps. Now, if I increase the voltage, those are rated at 2.7 volts, but I've been trying to be gentle. We'll take it up just a little bit. I could really touchy at the small of a voltage. Right there. Take it on 2.6. Let's leave it. Nope. Come on. It's really touchy. Okay. So, what I'm trying to do is I obviously don't want to overcharge, but you can see this thing's still taking current. So what's happening is that the electrical potential. So your capacitor is two plates not connected. So to my fingers like that. Pretend this is not connected to my hand. There are two separated plates by a dielectric. So a non-conductive something. It could be glass. It could be mica. It could be plastic. And an electrical potential builds on the plates, and it slowly can get over, right? So we're charging up those plates, and it's going to reach a point where it's not going to draw any more current once it's full. So you'll see that digit slowly going down as it charges. And the link of this video is meant to show, like, this is how much energy I can put into this. I'm going to go ahead and overdrive it just a bit so you can see. This is not ideal. Don't do this to your capacitors. There we go. Right, so you can instantly see now it's drawing less current. Back down to 2.2 now. So if I let this run, and you can see how long it would take, it would eventually fully charge those capacitors. And as it's charging, it's drawing less current. So it's like filling its mouth. It's taking all it can take, and then it's saying, you know, I'm less hungry. I'm less hungry. You see less current going out into the circuit now, and that's happening as it's filling up those caps. So I want you to imagine you hop in your electric car 50 years from now, and you've got your capacitor bank on your wall in your garage, and you know you're going to take a long drive, so you plug into your vehicle and you dump energy from the capacitor bank on your wall to the capacitor bank in your car, and you're charged in minutes or seconds. Because I know it looks slow as we're talking about this and it's charging up, but right now this is going faster than a battery. This is able to charge much faster than the equivalent size battery. I can unplug this and we're ready to go. So larger supercapacitors, you can do some real interesting things with. These are 2.7 volts. These are meant for maintaining memory on ICs on a RAID card. That's all they're supposed to do. They're not really higher voltage. You do have SuperCaps for starting cars. You can actually find people online who run cars on a SuperCap, as an example, the internal combustion, that is. So there are lots of experiments about graphene, and I feel like graphene is a technology that's sort of the cold fusion of my generation. And we keep talking about how graphene is going to be the next thing, yet I still see no commercially viable products entering the market. Anyhow, I just wanted to show you some supercapacitors from a RAID card and what they're doing. Like I said, this will be glowing for days. So these LEDs, being the only draw on this, will run 24/7 for multiple days at a time. Of course, look how much current I'm dumping in at this voltage. It's not a surprise. So again, during the length of shooting this video and everything else, we're up to 0.15 or down to 0.15, amp. So we're not, it's a tenth of an amp going here. So we're not really pulling a whole lot of current anymore. So there it goes, down to 14. So eventually it'll hit 0. I'm going to go ahead and disconnect this fully from the power supply here. It's a little loose. Which, I don't know which one of these connectors is loose. Something in here is... Oh, it's the resistor. Yeah. Ooh, there you go. Shoving in the breadboard is not the most ideal. But so what this guy's going to do, I'm going to set it right under the glass where I had it previously when I went on my work adventure out of town. And it'll sit there and glow for a couple days. Got kind of used to it. Anyhow, I hope this makes you think about capacitors in an interesting way and what that means for us as a future. Maybe you'll be the person who invents better capacitors for energy storage. I don't think batteries are the way we should be going. I really do believe that our next breakthrough in materials science is going to be a supercapacitor that allows us to store energy. You could dump, hundreds of amps into a massive capacitor and build it up, and then have it ready to draw off of with minimal losses. So that's the dream, I think. Anyhow, supercapacitors. They're freaking cool, man.